The second type, or the third type of transformation that we are going to talk about, is when you have a number inside the bracket with the x. So now you see that the value is actually x minus h in bracket squared. So this is a totally different transformation than if you have it outside. So this is different than have this, right? Because this is inside the bracket with the x. So we're gonna, as we did earlier, we're gonna do the same thing with Desmos. We're gonna graph the different kind of functions that we have here to see what kind of transformation we have. And as usual, we always compare to the parent function y equal x squared. So here's my original function, y equals x squared. And then I'm going to try to graph y equal x minus 2 squared. So that's our first function. So describe the transformation for me. What do you see? It moved to the right 2. Okay, so we see that now the vertex, it used to be at 0, 0, right? But then it moved, eyes on the board, everyone, please. It moved to the right 2. Now my equation is y equals x minus 2 squared. So where do you think that movement to the right 2 came from? This right here, right? See that 2 here? That's what made it move to the right 2. Now, what would be your vertex here? What's your vertex? 2, 0. Okay. Let's look at the other example, and then we'll kind of find a pattern, okay? Y equals x minus 4 squared. What happened? Move to the right how much? From the original one. How much did it move to the right? 4. Okay? Remember, we always compare to the original, which is y equals x squared. What's your vertex for this one? 4 and 0. So what part of the vertex is it changing? The x value or the y value? The x value. Okay. Now, your next example is y equals x plus 1 squared. So where do you think, if I graph this, which way is it going to move? To the left. Okay, let's see if that's true. So y equal x plus 1 squared. So you see that now it moved to the left one. So is it the same as what you see inside the bracket, or is it opposite to what you see inside the bracket? Opposite. And this is the trick with this one, is you have to be careful. If you see a negative, that means it's going to move to the right too. If you see a positive, that means it's going to move to the left. So it's opposite to what you see.
That's with the exponent.
That's because, it's not because of the exponent. It's because if you guys remember, the equation looked like this. Y equal bracket x minus h. So because of the example, because the equation is x minus h, so the minus is already there, right? So the minus is already there. That means 2 is positive. Okay? But the minute that my value is negative, negative and negative makes a positive. So that's why it becomes a positive. That's right. Okay? So always think about it. If it's inside the bracket, it's opposite to what you see. If it's negative, that means it's going to move to the right. If it's positive, that means it's going to move to the left. Okay? What's your vertex for this one? For x plus 1 squared? minus 1, 0. So if I look at this one right here, it's going to be minus 1, 0. You see that? Good. Now what was my last one, right? What was my last one? Y equals what?
Y equals x plus 3.
X plus 3 squared. So y equal x plus 3 squared. And it moved to the left 3. Okay? So this is how we're going to call it. What do you guys think it's going to be called? The transformation. Horizontal translation. That's correct. And then this time it's going to be either to the right or to the left. Because horizontal, right? If I'm standing, I'm moving horizontally. That means I'm moving right or left. If I'm moving vertically, that means I'm going up or down. In this case, it's a horizontal shift, right? And it makes sense it's horizontal. Eyes on me, please. It's with the x, right? It's in the bracket with the x. So x is horizontal, right? We know that the x axis is a horizontal axis. And since it's with the x, it's horizontal change. Okay? So let's write this in the table. All right. So y equals x minus 2 squared. What's your h value? What is it? 2. Because it's supposed to be negative. It is supposed to be negative. So that negative is supposed to be there. So that means my h is just 2. Which way did it open? Up. Did any of them open down? No, because the a value did not change, right? So they were all opening up. What happened to your vertex? 2, 0. So if I go back here, right, the vertex is 2, 0. Okay? Can you guys tell me what is the axis of symmetry for this one? X equals 2. That's right. So if you look here, if I'm going to draw axis of symmetry, it's going to be x equals 2. So the vertex is 2, 0. The axis of symmetry is x equals 2. So in this case, we're going to say that it's a horizontal translation. Two units to the right. Doesn't change. It's 135. Right? The only thing that's going to change your step pattern is an a value. That's it. Okay? Step pattern is going to be the same. What's the h value? 4. Vertexes? Axis of symmetry? X equals 4. Horizontal translation, 4 units to the right. What's the h value for the next one? -1. Remember, negative and negative, right? So technically, it's supposed to be a minus. X minus -1, that causes the positive. 2 negative after each other causes a positive. So that's why h is -1. and my vertex is -1, 0. Axis of symmetry is x equals -1. And it's a horizontal translation. 1 unit. Which way? To the left. And for the last one, h is -3. Vertex is -3, 0. X equals -3. And horizontal translation, 3 units to the left. So, when h is positive, which is greater than 0, which way is it going to move? To the right. Now, we have to be careful that how is it going to look inside the bracket? How is it going to look inside the bracket? X minus h. So this is how it's going to look inside the bracket. It's going to look a negative value, but it's not a negative. It's a positive. If h is negative or less than 0, the parabola shifts to the left. And then how is it going to look inside the bracket? So the value of h describes the horizontal translation. Of the parabola. It provides the value for the axis of symmetry and is the x value of the vertex. Okay? So h is the x value of the vertex, k is the y value of the vertex. No? Isn't that what we learned like 10 minutes ago? Right? We learned that k affects the y value of the vertex. And now we learned that h affects the x value of the vertex. So that's why we call the vertex the hk. Okay? So the vertex is hk. I'm gonna refer to it too many times. Okay? So the vertex, so when you look at your quadratic equation, hk, they're going to represent your vertex. Because in reality, we're not going to only deal with one transformation at a time. We're going to deal with multiple transformations. We're going to be able to recognize them all together. How many of you are lost right now? Mm-hmm. Good. I think that I'm doing my job. No, I'm just kidding. Okay. You guys have to put it together right now. Okay? We learned in this page, we learned that the k value is affecting the y of the vertex, no? And we just learned that the h value is affecting the x of the vertex. So h and k make up the vertex. So when you see it, you're not going to see only this or only this, right? You might see both of them. You might see one at a time, but you might also see both of them together in the same equation. And you need to be able to see that this is the H, this is the K, they're both making the vertex.
Can I ask a question?
Mhm.
Is it because of the exponent? Is that why it's changed from the K to H?
It's because it's inside the bracket. Yeah. Right? So because it's not outside, it's inside. So technically speaking, eyes on me for a second. If you're going to look at the whole thing together, okay? Oops. 1 second. One more. One more. Okay. So if you're going to look at the whole equation, the whole equation is going to look like this. A bracket x minus h squared plus k. So this is all the transformation all together. A is the one that we learned yesterday. K is the one that we learned today. And h is the one that we learned today. So that's putting all of them together, all of the transformations together. So if you look at this, if I give you an equation that looks like this, this is all three transformations. That's correct. Because H and K are the vertex, so now my vertex is 1 and 3. Right? So this is your A value. This is your H value. And this is your K value. So I have three things happening. I have a vertical stretch because of that 2. I have a horizontal translation 1 unit to the right because of that 1. And I have a vertical translation 3 units up because of that 3. So I have three things happening. But we're going to do more examples of this. Like, I'm not expecting you to put it all together by yourself. Okay? But I want you to understand that they're not going to happen one at a time. We teach it one at a time, but then we're going to have to put it all together. Okay? At this point right now, I need you to understand this. The vertex is composed of the H and the K. That's what the vertex is made up of. Okay? Mm-hmm.
If you're going to do the step pattern, would you use 2 and then times that by 135?
Correct. So your vertex is this, and then your step pattern is 2 times 135 because your A is 2. That's right. So you're going to look at your vertex first, which is 1, 3. And then from that, you're going to go up 2 over 1, up 6 over 1, up 10 over 1. Because it's 2 times 1, which makes it 2. 2 times 3 makes it 6. 2 times 5 makes it 10. So now your step pattern is not 1, 3, 5. It's 2, 6, 10. Okay? Okay. So let's look at the bottom example right here. And let's, first of all, state the transformation and then graph. Okay? So if I'm going to state the transformation here, what's happening? What does that 2 do to my graph? Horizontal translation, yeah. You guys have to give me the whole sentence. 2 units. Why to the left? It's technically negative. That's right. Because negative and negative make a positive. Okay? Good. So I dealt with this. Now how about this? That's the K value, yes? Okay, K does what? Yeah? This is my transformation. I'm done naming my transformation. Now to graph, I need to know where my vertex is, and I need to know what my step patterns are. Okay? So vertex is what? Be careful. -2, -3. Remember, the vertex is opposite, the x value of the vertex is opposite to what you see. -2, -3. Okay, step pattern? 1, 3, 5. It doesn't, the A value is 1. So your step pattern is 1, 3, 5. So, I'm going to have to locate my vertex. So my vertex is at -2, -3, so it's right here. Are you guys okay with that? So -2 and then -3. And then from that I have to go up 1 over 1 to both sides. Then I have to go what? Up 3, so that's 1, 2, 3 over 1, 1, 2, 3 over 1. I can fit the next one, so I'm going to go up 5 over 1, up 5 over 1. I'm going to give you time to do the next question, okay, and find the answer for it. Any questions?
Why we didn't cover the magnitude of the x dy?
What do you mean? Like the axis? Oh, just because I want to make sure that I have room for everything.
Okay.
Okay? So I changed my axis just because I want to make sure that I have enough room to put
Okay.
my graph.